Alright, so this video we're just recapping what we went over in class and specifically about the truncus. The very first bit of key information you need to know is that a truncus has this rule, 1 over x squared. The second key information is the fact that the truncus looks like this. It looks a bit like a trunk. That's how you can remember it. Trunk. It looks a bit like a trunk. We also need to compare this y equals 1 over x squared with y equals 1 over x. So you'll remember this from our previous lessons. And notice how it's different to this. They both have the same asymptotes when they're in this form without any transformations applied to it. But there is a key difference. And we're going to explore that difference now by going through this table of values. So let's begin. So when I have x equals -4, when I put that into 1 over x, I got -1/4. So in other words, when I put 4 in, I got -1/4 out here. But now, when I put -4 into 1 over x squared, I'm going to get 1 over -4 squared, which is going to be 1 over 16. All right, something very important just happened. I put in a negative x value and got out a positive y value. And that's going to happen throughout it. So when I put -3 in, I'm going to get -1 over 9. When I put -2 in, I'm going to get 1 over 4. This is going to be 1. This is going to be 4. This is going to be 100. That is very important. The fact that when I put a negative x in, I get a positive y out. So now when it comes time to sketching it, I would go, when I put -4 in, I get -1 over 16 out. Let me put a dot here. When I put -3 in, I get -19 out. -3 is going to be a bit higher up. When I put -2 in, I'm going to get a quarter out. So it's going to be a bit higher up again. When I put -1 in, I'm going to get 1 out. -1, 1. And when I put a -0.5 in, I'm going to get 4 out. 4 here. And then of course when I put this in, it's going to be off the graph. Alright, let me draw it. I apologize for the bad drawing. It's hard to draw on this computer. There we go. Notice the fact that I don't have what y equals 1 over x has, which is the ability to produce negative y values. The squaring it has, in essence, flipped it up. Let's now look at my other side. So it's just going to be 1 over 16, 1 over 9, 1 over 4, 1, 4, 100. And of course, I can't have x equals 0, because if I was to put 0 there, I'd get 0 squared is 0. I can't have 1 over 0. That goes away. And remember, that's how we get our asymptotes, which is exactly the same logic as what we saw in the previous lessons. Let me now graph this. So when I have 0.1, 100. I unfortunately can't draw that on my graph. When I have 0.5, so a half, I get a 4 out. So half. Notice that it isn't on the y equals 1 over x line. It is different. I am getting out different values. 1 over 1 but is actually the same value. So 1 over 1 is the point where these two graphs touch. 1 over 1. 1, 1. 2 is going to give me a quarter. So 2 is going to give me a quarter. So it's below y equals 1 over x. 3 is going to give me 1 over 9. And 4 is going to give me 1 over 16. It's all going to be below it there. Now this is going to be hard to draw. I'm going to have that intersect. And then it's going to go up. Perfect. So that is just a comparison of y equals 1 over x squared and y equals 1 over x. Let's just talk about it a bit more. So this is just taken from the textbook. And as we noted before, y is undefined when x equals 0. That's our x equals 0 asymptote. No problems there. There is no x value that will produce a negative y value. We talked about that as well. There's no x value that will produce a negative y value. And that's because we're squaring. As x approaches infinity, y approaches 0 from the positive direction. y approaches 0 from the positive direction. And you can see that by the fact that the line is getting closer and closer and closer to my asymptote, and therefore is approaching 0. As y is approaching negative infinity, as x is approaching negative infinity, y is approaching 0 from my positive direction. So again, the same logic. My line is slowly making its way closer to the asymptote and is therefore approaching 0. As x approaches 0 from the positive direction, my y is approaching infinity. As x gets closer to 0, my y is increasing. So too, as x approaches 0 from the negative direction, my y is increasing as well. We also have this kind of standard forms with the letters. Let's zoom in a bit. My x is causing a dilation. Don't worry too much about that. I then have minus h and k. And this is going to tell me what my asymptotes are. So here it tells me that the asymptotes will be the lines y equals k. So I keep that positive, or if it's a negative, I would keep that negative. And x equals h. So notice the sign has changed. Here it's minus h and there it's h. We touched all that in our previous lessons. Let's now keep chugging along. I have this. Notice that this minus 2 is different to what we were looking at before. And as you probably guessed, that negative 2 is going to shift it down 2 spaces. So now my horizontal asymptote will be y equals negative 2. If you had to prove that, I could put negative 2 into the formula and get negative 2 equals 1 over x squared minus 2. I would then plus 2 to both sides and be left with negative 2 plus 2 is 0 equals 1 over x squared. Negative 2 plus 2 is 0. I'm left with this. Is there any number I could put in my x spot to give me 0 as an output? Again, this is all just repeating what we did in the last lesson, and we know that isn't true. So this proves that my y equals 2 is my, y equals negative 2 rather, is my asymptote. Let me rub this out. My vertical asymptote is simply going to be x equals 0, because if x were to equal 0, I would get 1 over 0, which we know isn't possible. Finally, I draw in my truncus. Please don't get it confused with 1 over x, so they're both going to be like this. And I notice the fact that I have 2 x-intercepts. So I would have to find what they are. To find x int let y equal 0. I'm going to let y equal 0, get 1 over x squared minus 2 plus 2 to both sides. Do some rearranging. I'm going to get x squared equals 1 over 2. Okay. I then am going to square root both sides. So I'm going to get the square root of plus or minus the square root of 1 over 2, which is better written as this. The positive one, I don't need to write that plus. I could just do this. The positive one will be on this side, and my negative one will be on my other side. So this is what it's going to look like. Let's now come down here and go to another one. As you probably guessed it, just like 1 over x, this minus 2 is going to cause a shift of 2 spaces to the right. Again, how do we know this? We know this because my denominator cannot be 0. My denominator cannot be 0. So within these brackets here, if this was 0, then I would get 1 over 0. So x minus 2 cannot be 0. And then after rearranging, it's quite clear that x cannot be 2. So therefore, this is my asymptote. I then draw in my y asymptote, which again hasn't changed. I then draw in my equation, my line rather. Draw in my line. And we see the fact that I have a y-intercept. So I go to find my y-int, let x equal 0. Y equals 1 over 0 minus 2 squared is going to be the same as 1 over negative 2 squared, which is going to be the same as 1 over 4. So this will be 1 over, whoops, don't make silly mistakes, 1 over 4. And that will be my y-intercept. I've added in another question which isn't in your booklet. So let's now compare this question. Let me get a big one. Let me compare this to this. How are they different? Hopefully it's obvious to you. It's this negative out the front. That negative out the front is doing something to it. We know that it is reflecting it in the x-axis. We know that my asymptotes will be the same. If we know that x equals 2 will be my vertical one. And we know that my y will be y equals 0. All the same logic applies. But now, because of this negative, it's going to be reflected in my x-axis. Sorry for the poor drawing. There we go. So this is what it's going to look like. So notice how it's different from this. Now, I imagine many of you might be concerned that you'll forget to reflect it in a test, for example. You'll forget that this -1 is causing a reflection. Don't be too afraid if you forget to reflect it initially, because when you come to find the y-intercept, that should tell you whether or not something has gone wrong. So for instance here, I have my y-intercept. Let me solve what my y-intercept is. It's not letting me scroll across. Let me just do it here. So to find y-int, let x equal 0. So here's my formula. I'm going to go y equals, let me zoom in, -1 over 0 minus 2 squared equals -1. -2 squared will be 4. So I'm going to get -1 over 4. And that makes sense because I'm negative down here. So this point here will be 0, -1 over 4. Notice over here, I didn't get -1 over 4, I just got 1 over 4. So finding where that intercept is going to tell you whether or not you have done the correct reflection. But hopefully this was helpful to you. Again, these videos are just supplementary. Maybe you just want to hear the content again. Maybe you were away for the class. You don't need to watch these videos. They're just here to help you if you need it. So we covered how to graph standard truncuses, how to apply some simple transformations, either vertically or horizontally. We looked over this kind of stuff, and filled out a table of values. In the next video I'll put up, I'll go through the rest of the examples in the booklets. So if you do get stuck at home, you'll have this as a resource. So check out the next video for that. But all in all, I hope you're doing well with maths. And if you have any troubles, don't feel any hesitancy to let me know. Send me an email, talk to me after class, anything you need.